Hey, Chem20s, Mr. Jukley again. We are wrapping up our all of our solutions here. Sorry, my microwave is beeping at me. We're wrapping up all of our, not our solutions, our stoichiometry here today. So in the last video, we talked about titrations. We saw these titration curves. I promised that this would be a very short video. It's definitely going to be. We're on page 23, and we're going to be talking about our acid-base indicators and selecting an appropriate indicator. So here I've got a titration curve. So it looks like we're starting with an acid, and then we're going to end up with what looks like a really strong base. So a strong acid with a strong base. And we notice we've got this buffer region down here as we add more and more of the base to the Erlenmeyer flask. And then we get to this ridiculously steep area over here. In the middle of that steep area, and if it's a strong acid with a strong base, we should have our equivalence point. Equivalence point, the point where all of the acid matches all of the base. So the hydronium and hydroxide cancel each other out perfectly. Awesome. So that equivalence point is right there. We want to now select an indicator that will show us when we've reached that equivalence point, or at least show us somewhere close to that equivalence point. Now, I've mentioned this before. As I go from the acid to the base, right, along this really, really steep line right here, it's almost no volume that needs to be added once we get to that steep line. So what that means is our best indicator is going to be really, really close as possible to that equivalence point. But realistically, as long as that indicator changes pH somewhere along that, that really, really steep part, we're probably good to go, right? Because it's not a very big change. So for this first one here, we want to select an indicator. There we go. Select an indicator that would be appropriate to use with this titration. So knowing that our pH is right around 7, our equivalence point, sorry, is right around 7, and knowing that it changes, so I'm going to estimate that to be 4, I'm going to estimate that to be about 11 or so. Realistically, it could be anywhere from 4 to 11, but again, we want that color change as close to 7 as possible. So here I am in my data booklet on page 10. Very, very nice. Let's scroll down. So let's see, bromo cresol green, 3.8 to 5.4. That's reasonable. It's kind of on that steep area. Methyl red, 4 to 6. Oh yeah, that's on that steep area. Chlorophenol red, 5.8 to 6.2. That would be reasonable. That's good. Bromothymol blue changes between 6.0 and 7.6. So I'm going to put like 6 check marks because our equivalence point should be right in the middle of that. So bromothymol blue would be perfect. Ooh, phenol red would be great too. So many check marks. If I knew how to do a check mark backwards, it would be perfect. And then, you know, phenolphthalein, not so much. That's getting pretty high and pretty high. So yeah, I'd say those ones are kind of out of the range. These are the ones that we'd really want to look at. Not even that one. These are the two that we'd really want to look at based on that equivalence point. So I'm going to go ahead and use bromothymol blue. That is not what I'm looking for. Bromothymol blue. Okay, so what is the end point of this titration given the indicator selected in part A? So the end point is going to be between, I got to go back because I forgot already. The end point is going to be somewhere between, let's clean this up. It's a little bit longer of a video because I've got a mess going on here. Somewhere between 6.0 and 7.6. So 6.0 to 7.6, and of course that's going to be our pH. So that's going to represent our end point. There we go. What is the equivalence point for this titration? Well, it's a pH of exactly 7. Right, strong acid with strong base. And then what color change are we expected to see from this? Well, okay, I'm skipping back and forth here. We're starting with an acid, and it's turning to a base. Starting with an acid, turning to a base. So we're starting with a lower pH side, which is, let's see, 6.0, and when it's at 6.0, it's going to be yellow. So we're starting with it being yellow. So that's over here. I'm going to label that on my graph even a little bit more as well. So it's going to be yellow over here. And now I want to know when it reaches this equivalence point. And when it reaches that equivalence point, we're going to have a pH of 6.0 to 7.6. So let's go back to our data booklet. What color is it going to be between 6.0 and 7.6? Well, it's going to be a mixture of yellow and blue. What's a mixture of yellow and blue? Well, it's going to be green. So it's going to change from yellow. I'm having a hard time with the felt pens here. And it's going to change to green. So in this equivalence point, it's going to be green. And then if we add too much of the base, what color would it change? Well, it would change to blue. So if we kept adding, it would be blue. But it's the color change at that equivalence point that we're really looking for. Cool. We could try it out with this one as well. So same sort of thing, but in this case, we've got a base to start, and we are adding acid to it. Base to start and adding acid to it. So we could use bromothymol blue again. No problem. Again, what is the end point? So that's about 6.0 to 7.6 for our pH. The equivalent point is a pH of 7. And what color change would we observe? So in this case, because we're starting with a base, it's going to start out as blue. And then in our end point, it's going to change to green. And then if we were to keep adding it, it would switch to yellow. If it switches to yellow, we know we've gone too far, so we should see it blue changing to green. Finally, why would bromocresol green be a poor indicator for this titration? I don't know, poor is kind of an interesting word here. It's not so great because the color change isn't right at the equivalence point. That being said, you could probably still do a pretty good titration with bromocresol green. Just kind of thinking about the bromocresol green, where is it here? Changes between 3.8 and 5.4. 3.8 and 5.4. So let's see. 3.8 is somewhere in here. 5.4 is somewhere in here. Right, so it's still on that steep part, so it's still okay. It's just there's better choices out there that are right close to our equivalence point. I realize that's getting kind of messy there. Cool. Last thing that I'll get you to check out here is just the step-by-step titrations. You will be doing this in Chem 30 if you are choosing to move forward and take Chem 30. So please keep that in mind. It's a very important skill for lots of different chemistry courses, Chem 30 University Chemistry. So just have a quick read through of this. And then after you're done that, hey, guess what? Our entire Stoic unit has been completed, which is excellent. Good job, everybody. I'm so happy about that. I'm proud of you for the work that you're doing. Keep it up. Anyways, I'm going to say bye for now, and we'll talk to you again soon.